Welcome to Austin World. It's a commonly known game where we're jumping from square to square in a small 8-bit map, also common to Mario, which copied us. Except for this one, we're going to be applying the principles of physics to the problems themselves. So as you can see, in the beginning of World 1/A, young Austin is jumping on top of platforms. He gets the protein to increase his mass by 170%. But if you know anything about kinematics, you'll know that mass is irrelevant to kinematics. Furthermore, he has to jump from a platform on top of a Moogba. We're trying to find out the distance that it takes and how long it's going to be taking Austin to be jumping on top of the Moogba. Now, to start with, the first kinematics equation we're going to start involves us trying to find a final y distance equaling the y0 plus initial velocity times minus 1/2 gravity time squared. Well, our y final is going to be 0 because we're landing on ground level and we're starting 4 meters high. As we mentioned in the question, the initial y velocity is going to be 0.5 meters per second and our gravity value is 9.8 meters per second squared. Now, as we simplify this equation a little further, we'll realize we have 4 meters plus 0.5 meters per second times time minus 4.9 meters second squared time squared. Using the quadratic equation, we can be making sure that t is on one side and getting the equivalent values. So with the quadratic equation, we end up getting time equaling 0.956 seconds that Austin is in the air. So with this, we're trying to find out how far he's jumping. Now with the horizontal kinematics equation, x final equals x initial times initial velocity times time. X final is what we're trying to find. The distance that we start out is going to be at 0 meters, and our initial velocity was 2 meters per second times the 0.956 seconds that we have just found. Now, plugging that into our calculator, we find out that the x final is 1.912 meters. And that is how far Austin has to jump in order to land and squish the Moogba.